Hey everyone, my name is Matt Kosovec, and today we're going to be talking about the new MCP server for DataForge. Looking at where we're starting in our example here, we have a Power BI report, which is a BI tool directly plugged into a PostgreSQL database. And right now, there's a bunch of issues and problems with it, so we're going to fix them all, and we're going to migrate the entire solution to an enterprise-grade data solution built on top of Databricks by leveraging DataForge's architecture and services. Quick overview of our setup, and then let's get it going. On the left, we have a Claude Code terminal. On the right, we have the DataForge UI, where you'll be able to see the build happening live and executing against the Databricks environment. Let's give it a quick prompt. The goal for this session is to convert the existing Power BI data model into an enterprise architecture using DataForge and Databricks. You have access to the existing Power BI report, the DataForge MCP server, and a target data model spec file. I also want you to convert the existing Power BI report to point to the new data model. Use the MCP demo project in DataForge and the MCP demo schema in Unity. Okay, here we go. We're going to be fast forwarding and then pausing at the important parts. You can see it immediately found an issue with the existing Power BI report by looking at the target data model spec and the DataForge MCP server. Fast forwarding again, and you'll see that it builds a large number of pipelines and also then immediately begins to ask us business questions about how we want to interpret the data because the Power BI report was wrong. Looking at these questions, these are pure semantic questions and have nothing to do with how to develop the system or how to architect the solution. Now on the right, you can see the pipelines have been created and are executing. As of now, there's no logic in there. They're just moving the data through the Alloy architecture. Here we let it run for a sec. Another quick pit stop. It very quickly identified that it had a bad syntax, and this was caught during the build process. Didn't compile anything, tried to save a rule, didn't work, figured out a quick workaround, and self-healed. Fast forwarding through the majority of the build process, and here you can see a new issue was raised that it quickly identified how to fix using the DataForge framework. The framework itself escalated the issue, and now it's able to resolve it as part of the build process without having to build the entire solution and then go back and test it. The rest of the build does more of the same. DataForge checking the agent's work at build time, the agent checking its own work against the live data in Databricks, and ultimately finding all the bugs and reconciling the data to the correct values, even understanding that the original reports were incorrect. Wrapping things up by taking a quick look at the DataForge Lineage functionality at the column level and table level, and also taking a look at the data, it's also important to note that the only clarification that Claude needed in order to develop this entire enterprise architecture from scratch was just some business semantics around some anomalies in the definitions in the original Power BI report. No architecture, no landing zones, no pipeline design. Everything was handled with DataForge's framework and corrected at build time. Hopefully with this short demo, you're able to see how powerful the new DataForge MCP server is in helping to simplify the development process and workflows. You can see in this last screenshot, there are just a few handful of decisions that a human needs to answer that were purely semantic in order to go from a legacy Power BI report with a bunch of bugs to a modern data platform built on Databricks, leveraging the DataForge architecture, frameworks, and technologies. At DataForge, we've now solved the pipeline and platform problem. Next up are the two things that we either provided to the agent in this example or it asked for: the data model and the semantic layer. Stay tuned for those, and thank you very much.